So, our review for the celebration, our final celebration. So again, it's a celebration because you're celebrating how much you've learned. You guys have learned so much. And some of you have written me lovely notes, like on labs and stuff, that you've realized you've learned more than just chemistry, because everything is chemistry, right? So today you had your last study set and worksheet. You do have until Monday to get all those late assignments in. And then Saturday you have 2 labs due. So the Le Chatelier's lab, which is pretty straightforward. You just follow the video and fill it out. And then there's a video you just watch. It's actually very proud of myself. It's under 30 minutes. It's like 29 minutes and 48 seconds. And then there'll be something that strikes you in the video. It's for everybody, it's different. So 2 things, and you just write a paragraph about each one. So it will take you less than an hour. And you submit that. You can actually even just write the answer within the box there on the blackboard. So just please make sure you do those. And again, study, go back and do this. You're all in great shape. Dress up also on Monday. And so it will be the same. I'll be here at 5 o'clock on Monday. I'll be here on Saturday. I have more office hours tomorrow. So I have at noon, but at 1:15 I have a class tomorrow. And then in the evening I have an office hour. So if you have questions about anything, or Saturday morning, I will be there like always. So if you do your lab and you want me to look at it and stuff, and then Monday. And again, if you have an issue with Monday, just talk to me. You can take it early. I'm also doing a celebration on Tuesday with my other class. So if there's, yeah, just talk to me, even if something comes up on Monday. But if you want to do it early, we can talk. All right. Yeah, and I actually may be giving you more time than just 2 hours. I haven't thought about, I'm trying to get through each day. So it will tell you that on there. And I'll probably send you an email in the next 2-3 days about that. And so I'll let you know. So you'll have at least 2 hours. It'll probably be a little bit longer. And again, when you do submit, I'm going to ask you to come back on Zoom. One, so I can say goodbye to you and give you a virtual hug, and to make sure I can see it, because my other class had a celebration of learning yesterday, and I was grading them today, and the one girl, it says she submitted, I can see, and there's nothing there. It's completely blank. And so that way, it seems tedious maybe to all of you, but it's solace for me trying to find you then after the class is over. All right, so there is a lot on this exam. There's a lot of stuff that we did. So we did, right, the redox, writing reactions in redox. So that will be 1 page of it. We did stoichiometry. That will be the page that you're like, oh, good. So that's doing the math with the balanced equations. And then we did solutions in osmosis. We did all the pH and acid and base stuff. And then we did what was just today, the enthalpy, entropy, and equilibrium. So that's why I'm probably going to be giving you more than 2 hours, because there's a lot of stuff, and that way you can breathe a little bit as you're doing it. And so it may actually be like, I think it's 5 pages, because I spread it out a little bit, but it is similar. Somebody sent me an email last time and said, how similar is it? You know, it's not going to be exactly the same, but redo your study sets. You know, like the one today, this stuff, the last page, enthalpy, entropy, you should feel pretty good about it. You can do that page first. Even the stoichiometry, we just did that. But yeah, this, oh my goodness, that was a month ago. All right, so oxidation reaction, but you've got it. And so you can dress up however you want for Monday. And right, we just find the funnest hat. So you can be a koi fish, you can be a red ox, a blue ox, You can be a monkey in the middle like me, the sock monkey in the middle. You can be the snow princess like Tiffany. All right, so combustion, C6H14. I will
Plus
tell
oxygen.
you what's, and go ahead, what were you gonna say?
Plus oxygen.
Yes, it means plus oxygen and
Halo.
halo. Ah, everybody can sing. Please, when you're doing your celebration, you make your halos, do your little singing, because then you'll be giggling and people will be like, isn't she taking a test? What is she doing? Or he for Philip. All right, somebody other than Tiffany. Tiffany already got her point. You guys are limited again to 1 point. Anybody, what are my products?
You're gonna have CO2 and water.
CO2 plus water. So combustions are wonderful because you always get CO2 and water. The carbon, 6 carbons become 6 CO2s. So now we do our koi fish. And 14, this becomes 7. Because 7 times 2 gives us 14. And then we do our oxygen. So we have 6 times 2 is 12. And then plus the 7. So the oxygens are all over the place. Make sure you give yourself space. Make sure you just take a deep breath and do this calmly. So we need 19, which you're going to do one of 2 things. So Nancy, who just beautifully answered that, she's like me. She would put a 9.5, and she's like, okay, I'm good.
Not this time.
Oh, not this time.
No.
She proves me wrong.
I put 19
Or you'll
oxygen.
go, oh, it's not going to work. It's an odd number. And you start with a 2 in the front. That doubles both of these. So this becomes 12 carbons, so 12 CO2s. And I'm going to have 14 times 2, so 28 hydrogens. So I have 24 plus 14. This is why we're doing this question. These are the ones where students go, oh my gosh, the numbers are so huge. It can't be right. Combustions are the whole thing why the temperature's warmer and the weather's crazier, and plus it's 2020, so is because the numbers are large. We get a lot of CO2, so we end up with, what is that, 38? So 19 oxygens. So your coefficients are 2, and then 19, and then 12 and 14. Let's go ahead. Our classification is it's a combustion. So you just write combust. So combustion, again, just means it's burning. And we're going to do our Leo Gur because we have a halo. So write it over here. I recommend, again, writing out your Leo Gur. You're really good at these. I would go back and do the study set and the worksheet. And yeah, last page, the lab was really good practice too. But that way, when you get to this page on the test, you're like, I've got this. I love Leo Gur. You can sing your halo. I always write O-A-R-A and crisscross. I'm pretty sure you all did the same as me. It's beautiful. Oxygen is the second. Who's the greediest of them all? That was a question on your last celebration. I know Tiffany's like counting to neon. Anybody? All right, Nancy's
It's
name.
fluorine.
That was Kristen.
Yeah.
All right. So fluorine's the greediest, oxygen's the second greediest, which means the greediest one gets to be the negative, and it gets to be its normal negative. So this is a question that you've all probably been wondering. Some people have asked me, is this going to have everything, like everything from the first day? Oh my gosh, it used to. And I sat there looking at the test that I used to give for the final, and I'm like, holy moly, the amount of information you guys have learned. However, with that, from the very first test, you had to be able to know that oxygen is O, and that it's right, it's a -2. That's from the second celebration that we knew what the charges are. Well, now those charges are the oxidation number that we give to oxygen. So I'm not going to be asking you to do naming, but you have to be able to do naming to be able to write the equations and to do charges and stuff. So we're going to see stuff we've been building, like the moles. We learned that. That was on the first celebration, and we have it again here. Something before I forget to mention this, I always say to my students, and I don't remember if I said it the first day or the second day, but my real goal in this class is that you look at that you look at everything with new eyes and with new hope always, and with joy. And I really loved reading your guys' Thanksgiving or alkalosis, acidosis, gigalosis stories. Those were fun. But I said, when you walk in and when you sit down to take your celebration, just take a moment and look at your periodic table and look at it. And it should look totally different than it did 10 weeks ago. You should be looking at it. Even those of you who had chemistry before and you're like, yeah, I know everything about the periodic table. Hopefully there's something you learned. And so you should be looking at it going, wow, and just take a moment. And that's you learned that. You took the time to spend. All right, so oxygen is its oxidation number. Because it's so greedy, it's going to be -2. Hydrogen, we show it over here with the alkali metals because it likes to be +1. So anytime hydrogen's in a compound in our class, it's going to be a +1. Sorry, I'm off the screen. All right, so with that, we can actually answer a lot of these, but I'm going to go through, well, let's go ahead and do it. Oxygen's going from a 0 to a -2, so oxygen is my GER. That means O2 is the agent. So just a reminder, the agent has to be a reactant, the whole thing. Hydrogen doesn't change. So the Leo must be the carbon. So you can figure it out without doing every oxidation number. So we're not going to do the oxidation number. We can go back after we finish this, but the carbon must be the Leo, and the C6H14 is my reducing agent. So what Leo means, sorry, I was looking to see if the question is there. Leo is lose. I should have asked one of you to say lose electrons is oxidized. So whatever loses electron is what becomes the reducing agent. So combustion, yes, there's a halo. Element oxidized, this is Leo. So on your lab, I wrote the little hints there. The oxidizing agent is what we're labeling as the OA. You'll just have to add those in. So my Leo is carbon, my oxidizing agent is O2. All right, the next one. So barium hydroxide, so underline or highlight, and hydroxide is one of those polyatomics. So some things you want to make sure you have ready and organized on Monday is your periodic table that lists of polyatomics. Now, you may or may not have noticed that when we're doing the reactions, some of these show up, but it's really just the big 5 or 6. We haven't been doing much with the ites and stuff like we did with the naming. So you don't need this huge list as long as we have these, especially nitrate. We keep seeing that one a lot. All right, we need to look at charges. So barium is a +2. Here we go. And hydroxide's an OH. So if they have different charges, you need to put a subscript. So the 2 moves down to the OH. So does anybody remember what is the name of barium's family? The 2 A's. Tiffany's like keeping her mouth zip closed. Somebody knows her.
Alkaline
The alkaline earth metals.
Like 3 different. So Nancy, you already got a point, so you don't get an answer. And I heard like a couple different voices, but I saw Olga's thing light up. I don't know why. And I think Christy also answered, but she.
I think Huda answered too.
It was Shaylee.
Only one person gets it, so you guys can play rock, paper, scissors for who gets it. I was gonna give it to Olga because her name popped up, which means she must have been the first one to like. We're gonna do this from here on out. If you want the point, you got to turn your camera on to answer. So even if somebody else says it, but their camera's not on, so I don't see you. So if you want a bonus point, but I'm gonna give it to Olga because her screen moved. It's weird what I see, but hers moved up, and so I think I heard her voice. Just wasn't as loud as everybody else, which is a good thing either way. All right, iron 3 bromine. So it is the earth metals, the alkaline earth metals. Iron +3, and bromide is IDE is not a polyatomic, so it's just Br. And so here we go again. What's the name of bromine's family? Nobody wants to turn their camera on. Nobody wants to name bromine's family.
Brittany
Probably
answered
Brittany.
it, but
I
she
was
doesn't
gonna
have a
say.
camera.
I know. Did she say halogens?
She did, yeah.
Okay. I was gonna say when I see that thing flashing, I know it's Brittany. So she definitely has always played along. So she definitely deserves a bonus point in the last one. All right. So again, if you charges first, the charges determine your subscripts. So subscripts come from the charges. Arrow. We're just doing one-way reactions here. When you guys are writing these reactions out, doing the Leo Gur, it's a one-way reaction. All right. What type of reaction is this? I wrote it in blue. This is the swingers. Go ahead, Shaylee.
Is it a double displacement?
What else do you know about doubles?
That means it's not a redox because there's no halo.
There's no halos. Beautiful. Thank you, Shaylee.
You're welcome.
I love your voice. Anyway, so they swap. The first one, the barium goes with the bromine. So there's no halos. Said beautifully. They keep the charge that they had. So the barium keeps the +2 and the Br keeps its -1. So they keep their charges, and now we figure out new subscripts. So 2 comes down here. We have to write the Fe first before the OH. Why? So why can't I do like here? Why can't I just put the OH before the Fe? You already got a point, Brittany. She's like telling somebody else. Somebody else can be less shy. So 3 comes down here. Cats always come first. So the cation comes before the anion. All right. Subscripts first. So like make a note to yourself at the top of the page. Subscripts from charges before koi fish. Thinking if one of my colleagues came in and observed me, they would be totally confused watching me do this review, like koi fish and blue ox. What is she teaching them? But you all got it. You can all do this. All right, so we have to balance. So we'll just go back and forth. I have 1 barium. Here I have 2 OHs, and over here I have 3. So we're going to have to get to 6 OHs. You can make a little list if that helps you. So we're going to end up with 2s in front of the irons on both sides and 3 in front of the barium. So I have 3 bariums, 6 OHs, 2 irons, and 6 bromines. And we're good. And nothing down here. Leave it blank. Draw a blue ox. Draw a Christmas tree. Draw a snowflake. Draw a star. I don't know. All right. Lithium metal, extra words. It's just saying it's lithium. Do your halo by itself. All right, and nitrogen gas. Did you remember it's a diatomic? Nitrogen. Does anybody want to tell me what the diatomics are? There's 7. This is like really having to earn your bonus point. Maybe. So, nobody's taking me up on this? I scare everybody. Oh, go ahead, Olga.
It's fluorine, oxygen, nitrogen, chlorine, bromine, and iodine.
And then there's actually one more, which is
Hydrogen.
hydrogen. Yeah. So it makes the 7 nitrogen, oxygen, fluorine, chlorine, bromine, iodine. Acentine's too reactive because it's feminine. You look at her and your eyes burn out. So she's like a superhero. And hydrogen are diatomics. This is a combo. And we will do the redox. And so they combine. Don't bring the subscripts. When you combine at your periodic table, the lithium is going to be the +1. Those of you have your periodic table like up on your wall. I know, Monday after the test, you get to ceremonially maybe rip it down and burn it. And nitrogen's a -3 because it's over here. So this 3 will come down here for the lithium. So again, our little mantra, write it subscripts first from the charges, and then you do the koi fish. So don't bring subscripts across. And then you can put your little blanks, and we have to balance. So we have 2 nitrogens, put 2 there, that gives us 6 lithiums. And if you don't like having a blank, you can put a 1, or you can leave it blank in front of the nitrogen. So Leo Gur. Lithium 0 to +1, or the oxidation number always goes up for Leo, and nitrogen is gaining, so its oxidation number is dropping, and we crisscross. The comment, again, so you don't feel rushed, so I'm going to give you more than extra time, even though I think probably giving you extra time for some of you might be a bad thing because then you'll want to use all the time and dwell. But make sure you read, like I asked for oxidizing and oxidizing agent here. I have no idea. Sometimes I ask for what's reduced. So just make sure you answer my question. All right. So the N2 is your oxidizing agent and the lithium is your reducing agent. So down here, the answer is lithium and N2 for the oxidizing agent. All right, one more. So we have aluminum and magnesium chloride. So aluminum plus, there's no comma there, so they go together. And magnesium's in that 2A column. So looking at our periodic table, magnesium's a +2. Think about 2 months ago when we first learned charges and you were like, what, where'd she get that from? Holy moly. Or a month ago when I was doing the balanced equations, I remember Brittany was like, how do you know where to put the plus sign? And so hopefully now you're like, okay, added, we're going to put the plus. It's like anything, it takes practice. If the charges are not the same, you're going to swap. And halo, and we swap. So anybody want to tell me what we get? Somebody new? Or what type of reaction? Or if I'm going to do Leo Gur? Somebody's getting brave. So my coat had a broken zippers. I haven't worn it in forever, and so it got fixed this week. And I put it on just because it's so exciting when you get a new zipper. And then I remembered I found the leg. So the red ox now has 4 legs. I just don't know how to put the clay back together because I'm not that crafty. But we now have a 4-legged ox for tonight, which is exciting. So this is a single. I was waiting. I know Brittany's there like yelling out the answers. Nobody else wanted to say. It is a single. We have a halo, so it is a red ox, 4-legged red ox. And so the aluminum and magnesium switch. So aluminum is with the chlorine and the magnesium is by itself with the halo. Our last Aluminum is a +3. So again, your handy dandy periodic table, don't lose that. And chlorine's still a -1, so the 3 moves down here. So subscripts first. All right, we have to balance our chlorine. We'll have to get to 6. So 2's in front of the aluminums and 3's in front of the magnesium. And this is really tough. This was a huge hump. This is so uniquely chemistry, but you guys did amazing with it. Just go back and redo your homework sets, your study sets, so you feel comfortable with them. The keys are all posted, and you can also go back and watch the videos if you need a little bit more. So Leo Gurr. All right. Aluminum, that's the +3, means it lost electrons. So aluminum is my Leo. That means it is my reducing agent. And magnesium, so the chlorine is a spectator. I talk about them in the lab this week. So chlorine, nothing happened. It's just there. So the magnesium, the Gurr, again, its oxidation number always decreases. The Leo's oxidation number as you're moving forward. So my oxidizing agent is the whole compound that you start with. Again, the agent has to be a reactant. So the magnesium chloride is my oxidizing agent, and the aluminum is my element that is oxidized. All right, I actually want to go back to question number A, and I want to do the oxidation numbers of the carbon, just for the heck of it. So in the CO2, that's pretty easy. Oxygen's -2, so the carbon is +4. So here we go. This one's interesting. I may figure out what it is. That would be a good bonus point today. Do the +1 times the 14. So remember, we do these, I do my oxidation numbers, I always show up above, and I show my math below. And I recommend that, because if you do your math above and your oxidation numbers above, you're gonna get lost and confuse yourself. So this has to be -14, because they have to balance each other out. And then we have to divide it by the 6. So this one comes out really weird. It's -7/3. That's why I didn't want to do it before. It is not a charge, it's an oxidation potential. We're going from negative to positive, so it's oxidized. But oxidation numbers can be positive, they can be negative. We always show the plus and minus. They can be fractions, they can be halos. Just wanted to sing out of tune for you one more time. So let's do H3PO4. I'm going to write it big here. So hydrogen's +1. Hydrogen always takes that plus. Oxygen's -2. So -2 times 4 is -8. +1 times 3 is +3. So the monkey in the middle, which is how I'm dressed today. My monkey's holding the gnome up there. Yeah, I was thinking if there was a way you guys could decorate your Zoom. So it is a +5. So there's our answer, +5. All right. Just a reminder, right, if you don't have a printer, just make sure you write it all out in the same order. You don't have to write the questions out. You just need to write the answers, but nice and orderly. All right. What happens to the oxidizing agent? So let's go back up here. The oxidizing agent was Gurr. So Gurr became my oxidizing agent. So it gains electrons. So B is wrong and D is wrong. And Gurr always drops. So it's C. So it gains electrons, which is Gurr. The oxidation number decreases. All right, questions. You can color your redox, the bottom of the page. Apparently I printed not in color. Any questions? All right, let's move to the math. Here we go. Here's a quick question somebody can figure out. Maybe we should do this. Is this a redox? And how do you know? For the math, what type of math problem is it? Yeah, I can see Tiffany is nodding her head yes, and Brittany's. Anybody else want to answer that question? Olga's nodding her head yes. Somebody new? Get bonus point. It's worth the point. The point less to worry about. All right, what type of problem is this? It is we got a halo. What type of problem is this?
Combustion? Or no,
Oh, the
not
reaction.
combustion.
The reaction is a type of combustion because it's plus oxygen. But what type of? We're going on to the math now.
Decomp?
So this is an interesting Leo Gurr. So this will be the bonus that you can email me the answer. What's the Leo? This is a tough one to get. What's our Leo and what's our Gurr in that equation? All right, so do your Leo Gurr OA-RA. It's going to be really tough because I see what's going on. This is a limiting reactant problem. I don't know if that's what you said. I was thinking about something else. So
No,
200.
I said decomp. I was wrong.
Oh, yeah, no, it's not a decomp. It's a limiting reactant, and the way you can tell it is you're given both reactants. So you're given amounts, so you're given grams for both reactants. And several of you had emailed me about something else, and you commented, I really like the limiting reactant problems. And it is. It ends up being, for most students, the happy place on the exam. They're like, I got this. So you solved twice. The key, which you did really good with, so go back and redo. That worksheet was a tough worksheet. You don't have to do the whole worksheet. Just do a couple of these. That iron 3 oxide, or do the whole worksheet. We are solving for the Fe2O3 both times. You solve for what I ask you for. So my other class just had their quiz on this, and like half of them solved for the SO2, and I'm looking at it going, why'd they solve for the SO2? The SO2 is there to balance our equation, but we have to solve, and so I have to do all my math. The oxygen, I know, it's 32 grams. I'm going to pause. All right, let's go ahead and go through this. So write down your railroad tracks, and we add up from the periodic table the FeS2. So that's where you find your iron, this number, and then plus 2 of the sulfur. And you should get around 120. You can do 119.99 if you want. But around 120 grams to 1 mole. And this is where you want to label it fully. And then whenever you're using the periodic table going from grams to moles, it is always 1 mole. The next step is the stoichiometry, and the 4 is coming from the coefficient. So I recommend you just write in the coefficient how it is. This step is our balanced equation, and then that mole comes down, just 1 mole of it, and we go to 160 or 159.7 grams. You punch it in. Same with the oxygen. When you go from grams to moles, it's 1 mole, but the mole to mole step is from the balanced equations. And then the last step is going to be the same, but again, it requires the least amount of thinking. And at this point in the year, that's probably a good thing. And we punch it in. I forgot to punch it in.
I got 222.
Yeah, so it depends on, we're going to get 2 answers. So don't automatically put your answer in there. So around 222 grams, and our other one should be
202.
It is. Now, if you get 201, we're in the same ballpark. So that last digit might vary a little bit. So 201, 202 grams. You get 2 answers. And then what? This is where you do the hug and a kiss. Because if you don't do that, you're going to do something really weird with this number. The larger number is wrong. So cross it off. You cannot get there. Why is it wrong? Why do we always pick the smaller one?
Because
Go ahead.
because that one runs out.
Yeah, and so that is the limiting reactant is what you started with. So the oxygen is our limiting reactant. We've run out of oxygen, so the reaction stops. We can't make it to 222 unless we provided more oxygen. So there you go. You've all got it. All right. Balance. So the only subscript is the 2 oxygens, so I need a 2 here. I have 1 silicon, and that gives me 1, 2, 3 carbons. So you can leave it like that, or if you have to fill in the blanks, you would get 1, 3, 1, 2. Halo. Halo goes with the carbon. And let's do our oxidation numbers. So oxygen's our greedy one. So oxygen's not my Leo or Gur, because it's -2 on both sides. Here, the carbon has to be +2 when it's with the oxygen. Over here, the silicon's +4. So this is a good question. The silicon and carbon, which one is greedier? So which one's going to be the negative and which is going to be the positive? Well, whichever is closer to fluorine, and that would be the carbon. So there's probably not much tug of war going on here, but the carbon will get the negative and the silicon will get the positive. Oh, this is fascinating. So if we give carbon -4, because it's in the group 4, and the silicon the +4, something really fascinating happened, which is the oxygen did not change and the silicon did not change. The carbon goes through both oxidation and reduction. So your Leo and your Gur is the carbon. You can actually have 2 things be the Leo and only 1 thing be the Gur, but you cannot have a Leo without a Gur. And what happens in this one is the carbon is both your Leo and Gur. That is not going to happen to you on the celebration, but it's kind of cool to see it here. So your agent for both cases is the carbon, is the oxidizing agent and the reducing. Yeah. That's an interesting question. You won't be asked that question on there, so let's just move on. So, because you could actually, it would be debatable that you could say it's SiO2 for both of them, because it's the one that causes the other one to go through oxidation or reduction. But again, that's taking it a step further than what our class was, and I didn't realize that when I threw this question on here, so that I could post it for you last week, that I did that. All right, so let's start with atoms, which means nothing's in the bottom. You can draw, put your star, heart, and we're going to change atoms to moles, which means what famous number do we need?
We will use Avogadro's number.
Yeah, was that Huda?
Yes.
Mama Huda? All right. Which is what, Huda?
6.02 times 10 to the 23.
Yeah, it's really fun when we're in class because everybody will say it together. So 6.02 times 10 to the 23. So make sure you label still atoms, carbons, because we're going back to this equation. So 3 moles of carbon. And I'm solving for the SiC. So 1 mole of silicon carbide. And we're getting to grams. So 1 mole is like 40-ish, 40.1 gram, and then to micrograms. Anybody remember? Grams to micrograms. So you can either make it that funky symbol or the MCG.
10 to the negative 3 gram.
Yes. So micro is, oh, that's, no, that was milli. 10 to negative 6. That's what you meant, right? So 10 to negative 3 is milli, and micro is 10 to negative 6. So hopefully you get my answer. All right, actual yield. So this is where you state A over T equals your percent. So this is 55.5 micrograms over our 73.9 micrograms. So your answer up here is the theoretic times 100 will hopefully give us this percent of 75.1%. So sometimes I have to give you the actual, or if I give you the percent, then you multiply the percent times the theoretic. All right, percents do have sig figs, so we're doing the 3 sig fig rule. All right, let's look at solutions. Chemists have all the solutions. If you can't figure out my question up here, you can also just send me a fun cartoon that has to do with all this. So that will give Tatum something to do. She has to find a new cartoon for me. All right, which ones are soluble in octane? So octane is nonpolar. How do I know it's nonpolar? It's only, it's only carbons and hydrogens. Yes, remember that? Those of you who are going to take Chem 105 with me, this is pretty much the central theme of all of Chem 105 is you're either water soluble or you're not. So if you have only carbons and hydrogens, which is like the first month, we only deal with carbons and hydrogens. So you look for the thing, they like to mix with the thing that's most like them. The NH3 is polar. That's going to hydrogen bond. I'm not going to ask you about hydrogen bonding. This is ionic. Remember that though? That was the last test. They like water. This thing's nonpolar. It doesn't like water. Here we see the OH, so we see the H bond thing again. So no, that's not going to mix. This one would. This is a carbon with the 4 chlorines around it. This is a good question from the last test. But so this is nonpolar. When we did our Lewis structures, yeah. The other ones would mix with water. But these are nonpolars. They would mix with the octane. All right, solubility. So think of soda pop. We like low temperature. So low temperature and high pressure. So pressure is pushing it in. You're trying to keep it in the solution. So you want to keep it on ice. That makes it more bubbly. And you want to keep the pressure high. So once you open the cap, it pops and you get the bubbles all come out. All right, number 3, we add a solute. So which ones go up? It's actually 3 answers.
Boiling point.
Yeah, boiling point goes up, vapor pressure goes down, osmotic pressure goes up, freezing point goes down. Now, the thing that's interesting, the concentration, molarity would also go up because as The molarity is how much you have in there. So if you keep adding more, there's more in there. So the molarity will also go up. All right, number 4. This is a good question. So we take the number of ions. So there's 2 ions. So 0.08 Oz. That's where we go over the rainbow to Oz. 3 ions. So there's a calcium and 2 chlorines. So that's 0.15. You can write as OS. I'm just wanting to write Oz today. Thinking about rainbows. All right, this is 4 ions. 3 sodiums, and then remember the PO4, that's one of those polyatomics. So we put a parentheses. It all stays together in when it becomes an ion. So there's 4 ions, so that would be 0.12. But now it looks like it's ounces. So osmoles, you can write OS. This stays as 0.10. Why?
Because it's already,
Somebody was saying it, sorry.
I don't want to take it from somebody else, so.
Go for it. Nobody's jumping
Molecule?
to him. It's a molecule because it is all nonmetals. So carbon, hydrogen, oxygen, it's not ionic, so it's all nonmetals. And then pure water, we give it a 0 because there's nothing in there. So your low is the water, E. Your high, we're doing boiling point, I'm assuming, is whichever of these was the highest, which was B. And then we put them in order. C is my second highest, and then D, and then A, but pure water, the H2O is the lowest because that's 100. Anything you add to it's going to increase the boiling point. So this is our lowest boiling point, and this is our high boiling point is the B. If you are asked to list things in order on any question, do label your low and high because everybody logically does it differently, and so then I don't know. All right, compartment A and B are separated. All right, so A is 2% and B is 10%. So they're both sodium chloride. So what happens in osmosis is the water moves. That's what osmosis is the water moves to the higher concentration. So the water is going to move to the 10%. I like to draw pictures. So A and B are both wrong. The ions do not move. They cannot cross the membrane. The water moves from A to B, so C is correct. On E, initially A is lower, so that is hypotonic. So A is hypo. And the volume increases in B, so G, gorilla G. So we have camel C, gorilla G, and the concentration in B is going to decrease. So as you're adding, you're diluting it, you're adding more water. It's trying to this gets more volume, but a lower concentration now, until the two sides have the same concentration. So it seems interesting because we'd think, oh, the water would want to make it so the water level is the same, but it's actually going to be pulled to the side. The solute is attracting the solvent, so it actually gets pulled through. So reverse osmosis is where you make it go the other way. It's a way of desalinating the water, and so that's an important process for getting water, since most of the water on our planet has salt in it. Any questions? So do you want like 5 minutes or so to try this page for a few minutes, or you want to just go for it? I'll let you decide, Tiffany, since you're the only one I see, or Brittany.
I don't care, but go for it.
Just go for it. All right. So buffer, that's one of our concepts. What you're looking for a buffer, does anybody remember? You can answer again, just for the fun of it.
Like, it's the, I don't remember. I want to say it's the N, the sodium.
You might see a sodium. It's where you're going to see a weak with its conjugate. So it could be a weak acid. So you're going to see, like here, we see HF, and then the H is replaced by a sodium or a potassium. Apparently here I was doing a potassium. So B is going to be a buffer. A is not, because they're not conjugates. So the key is conjugates. So A doesn't work. C doesn't work because neither one of them has a hydrogen. And then on D, sure, we replaced one of the sodiums. Replaced one of the hydrogens with the sodium. So we got D. All right. The strong acids. I'm pretty sure when I wrote my rough draft, so you're going to, the formulas are given to you, and I also wrote the strong acids. So the list of the strong acids, HNO3 is a strong acid. And why that is important, what does a strong acid do that the weak, what's the difference between them?
It's only a one-way reaction.
Yeah, it's a one-way. And so now we talked about equilibrium this week. Our second one is going to be a two-way reaction. So if this is the acid, this must be the base. So the hydrogen is going to move over here. You either need to cross out the sodium. It's probably the easiest thing to do is cross out the sodium. Or the hydrogen and the sodium have to switch places. So you'll either put the sodium here. I'll just write it really light. You can put the sodium here with the NO3, or you just write it as NO3. So the acid becomes the conjugate base, and this guy picks up the hydrogen. So you don't want to write it HHCO3, you'd write it H2CO3. They may know this one's special. There's something else. This is our conjugate acid. Something else happens here. This is unstable, and so it breaks into H2O plus CO2. That's what goes on in our body. That's how we keep the pH of our blood balanced. So I'll just write it up above it. All right, if you see nitrogen, that's a base. So the water is your acid. So the water is going to give its hydrogen to the base. So remember, nitrogen base, alkaline. Or alkaloids, yeah, so C6H13, and it's the nitrogen that gets the hydrogen, and when you get the hydrogen, you get a plus, and then the water becomes hydroxide, that's the conjugate base, the NH3 positive is the conjugate acid, you see the hydroxide, hydroxide's going to push it reverse. So thinking about this, the math, you know, as much as some of you don't like math, and the oxidation reduction, you've got it. It's some of the pH stuff, that's studies that you're going to want to go back and review, because some of that was little stuff. But keep that in mind when you do your celebration. You don't have to get perfect. So do all the questions, do the best you can, and be like, it's okay if I forgot a plus or a minus and you lost a point. That's why you're going to dress up. So if you dress up, wear a fun hat, something. Yeah, and sing your halos. And you do like Kaylee. Kaylee's going to record for me the periodic table song. I totally forgot, Kaylee, when you sent me that email today. I was like, nobody's ever taken me up on this. So now I'm really excited. She's going to sing the periodic table song for me. So you can sing the periodic table song and or answer a question in the next like 20 minutes and get a bonus point, and or make a really awesome cartoon on your lab and your worksheet today. So you have those points and you're like, got this. going into this last celebration. You don't have to be, yeah, it's all point based. Final is same as all the other ones were. All right, the biggest thing on these is please state the formula. We're calculating pH. So which formula do we use when we calculate pH? The pH formula. So pH equals negative log of the H3O. I'm not going to go through every step of these. However, I gave you the hydroxide. So this is going to be our second step. Our first step, the only one that involves the hydroxide was this formula. So it's where you do the hydronium times the hydroxide equals 10 to the negative 14. So we would divide by the hydroxide. That would give us our hydronium. Then we punch it in. And this pH tells us what about our reaction. It tells us about our solution. It is basic because it's a high pH. And so again, make sure you go back. There were two study sets. There was one on the calculations. And the calculations, you just need to refresh yourself because you all had it. That was before Thanksgiving. And so that feels like, as Kaylee said to me yesterday, she feels like summer happened because it feels like, yeah, but I needed that break. That break was great. All right, next Wednesday at this time, you'll all be going, oh, we don't have Zoom. What do we do? All right, on this one, if you're given the pH, we do 10 to the negative pH equals the hydronium. So since I gave you the pH, you're going to punch it in like that. So 10 to the negative 4.44. And that would give us our hydronium. That would be our first step. And again, your second step would be the hydronium times the hydroxide equals, I ran out of room, 10 to negative 14. All right, so these were two-step ones. I guess they're all two steps. All right, number 3, what type of problem is it? Well, we have our list. This is going to be my acid. And we're neutralizing. So this is the NaVA equals NbVb. And this is my base. All right, so we're solving for the volume of the acid. So we'll divide by the Na. And the key with these, just the piece you have to remember, is the N means we take the molarity and we have to multiply by the number of hydroxides, which on this one, I'm going to do it just to remind you. It would just be 1, so it would just be the same thing. And then times the volume. And the normality of the acid, we do have a number, 1, 2, 3 molarity times 3 hydrogens. So molarity to normality, we multiply by the number of hydrogens or hydroxides. There was one, I remember on the study set or the worksheet, you had to go back to molarity. So there we divided. But just go back and practice so you're familiar with it. And all right. And buffer, this is where we do the Ka equals conjugate base, hydronium over our acid. So the acid is the one with the extra hydrogen. So there's my acid and there's my conjugate base. And you plug in. It's going to be your first step. Your second step is pH equals negative log of your hydronium. And we get our final pH. So I will leave those for you to practice because that's what this is. You print this up again and practice, but also go over your study sets. And then I'll be here Saturday or Monday before class. And you can also send me an email. We got one more page, but this is what we did tonight, so we got it. All right, was there any questions on the pH page? I'm trying to figure out why.
Did we go over number 8 on the last page?
Oh, you're right. I missed that. Thank you. Yeah. So which one has the lowest pH is going to be, lowest pH is the most acidic. It means the highest Ka. Highest Ka will be the strongest acid. So as you increase the acidity, you decrease the pH. The hardest thing here is they're all negative exponents, so it's A, HF, because it has the largest Ka. So lowest pH, this is a question, I think it was like on that lab, the cabbage lab. There's a few of you need to turn in some labs, so just, yeah. All right. This one, C would be my weakest acid. So that would mean it would have the highest pH and the least number of hydronium. So pH, because it's a negative log, it's the opposite of the hydronium. All right. Thank you. All right, last page. Enthalpy, entropy, and equilibrium. So the 3 E's, E. So negative, so exo. And enthalpy sign is the delta H, so it's a negative delta H. Entropy, where you're going, you start all looking the same. We have 3 to 2 moles, so it is decreasing. And that would be also a negative, so negative delta S. All right, and then we're going to calculate, you know how to do this, so 22.2 grams of the SO2. And then what? Change your grams to every chemistry student's favorite unit. Think back 2 months ago when you first learned moles. That was my video, right? I gotta go onto campus. So this is where we add up from the periodic table. That was the first celebration where you got to do this. This was back in October. This is back, like, yeah, before Halloween. All right. And then from our balance equation, SO2, we have 2 moles of SO2 and negative 323 kilocalories. Again, the units for heat are either kilojoules, kJ, or kilocalories. It's a unit. Just go with the unit. And the most asked question on this is, why didn't I put a negative? You can, I implied that the heat's released in my question was why I didn't put the negative there, but having done this long enough, it drives students crazy, so you can put the negative there. I'm fine with that. If I asked you, is it released or absorbed, you would say the heat is released, because that's what the negative means. So this is exo, means heat is released. All right. Now we're going to do equilibrium. So I'll give you a moment to try those. So if we increase the temperature, write the heat in. It's a product. So heat is released, meaning it's a product. Put your brackets. You don't have to put the brackets, but they do help If you increase the temperature, you can't move forward because you would hit the wall. So it would bounce reverse then, since you hit a wall. So it's increase in temperature goes reverse. If you add the SO3 again, it can't go forward to hit the wall, so it has to go reverse. If you take away the oxygen, it also goes reverse, has to move to the oxygen. And if you increase the volume, that's going to allow it to expand. And so again, this was Kristen, you'd asked me this question during the office hours. So volume, more volume gives it expanding. It's going to move to the side with more moles. So again, it went reverse. So they all went reverse. So we're trying to make the SO3 to go forward. So we want a low temperature and pressure, a high pressure. So high pressure will push it to the side that has less moles. And then we write our K expression, products over reactants, so the SO3 squared. SO2 squared, and the oxygen. And then go ahead and plug in your numbers. Is this the one? Yeah. I have to calculate it because I didn't put an answer. Oops. All right, I got 288. So the SO3 is 0.222. Again, you can leave the molarity off, but the pH and the K, our final answer doesn't have that, as long as your unit is molarity. And then my SO2 is 0.055. That gets squared, or you can just cube the denominator, 0.0555. And that's how I got 288. So before we do the next question, it was a question I forgot to ask in the homework. I just realized, what does this number tell you about the K, about the equilibrium, the 288? If K is greater than 1, it means you have,
Endothermic?
that's not what it was, no. The exo-endo is the delta H, that's something different. If K is greater than 1, that's a good thought, but if K is greater than 1, it means you have more products. So, or product favored. All right, the energy diagram, we did these in the homework. It's exothermic, so just a real quick, since it's exo, you're going to start high and end low. I'm just going to do a quick crude one. So look at your study set. All right, let's look at some of these true false here. So A is wrong. Why? You see the word disorder. Disorder is not enthalpy. Disorder is
Entropy.
Yeah. So A is wrong. All right, B, sublimation. Anybody remember what sublimation means? Sublimation means we're going from a solid, this was Halloween, dry ice, solid to a gas. So the gas law demos that had to do without liquid nitrogen. Well, that's bringing back a really good memory. So solid turning to a gas. So sublimation involves an increase in entropy. Yes, look at that. We have a true statement. So here's our bonus question, right? What's the opposite direction? What's the word? So sublimation is a solid turning to a gas. When snow forms, it's a gas becoming a solid without going through the liquid state.
Deposition.
It is. Katie, I don't think you ever answered before. Thank you. Yeah, so deposition. So the snowflakes deposit out of nowhere. All right, on C, that is actually true. I kind of alluded to it, but I never said that. So if the delta H is positive in the forward, then it's equal but opposite. So if it's positive in the forward, it would be negative 55 in the reverse. And D is wrong. So what does a catalyst decrease is not the enthalpy. What does it do? Anybody? He's going, I know. It is the activation energy it decreases. So that's why D was wrong. All right, we're almost done. So which changes will increase the nitrogen? So again, there's one somewhat like this on the lab, on the post lab, and it asks you what color you'll see. How you want to approach this is we first want to do our forward reverse. So if we add NO, actually let's look at this. This is endo. So that means heat is on this side. And then put your bracket. So if you add the NO, it can't go forward. Here's our equilibrium because it would hit the wall. So adding NO, it goes reverse. If you take away the oxygen, this is gone, so it has to move to make more. It goes reverse. If you lower the temperature, it goes reverse because you took away the heat, so it's going to move to try to make more heat. And if you increase the pressure, so, oh, this is the one, we had one on the study set. There's no change. Why is there no change? If you look at the moles, you have the same moles on both sides. So if you have the same gas moles, you don't have to worry about it. So now let's go back and answer questions. Which will increase the nitrogen? So nitrogen A, B, and C. If it shifts reverse, it's moving towards the nitrogen. D doesn't do anything, so he, and then temperature, if you increase the temperature, it goes forward. So that's going to increase K. And Nancy, that's back to the question you had been asking me during office hours earlier. And the last one, kinetics. So 3 ways to make it go faster. So anybody? Somebody whose name's that? A lot of you have your names up there.
The
I was
catalyst.
laughing. Oh, cool. Who said that?
Christy.
Christy with the awesome hats. I like covet her hats. So a catalyst, no, I was laughing because over the weekend, so I'd sent an email out to all the classes. They each were different, and if you responded. And so I was writing a list on the board because that way I wouldn't lose it. And so like your class, it was like this. There were like 12 names of people who responded. And then the other class, there were no names. I like ended up putting a big frowny face. I was like going, what's going on? One of the guys answered today. He like, yeah, you kind of missed the full moon. You missed the eclipse. It clearly said. And then he sent me another one. He answered one from back at Halloween. Like he must have been cleaning out his emails. And I'm like, you're finally reading all the emails I sent you. But yeah, I thought that was pretty funny. I'm like, he's like, I'm trying. I'm seeing if I can get a point, but he's fine in the class. I was like, okay. I was thinking of giving it to him just because I was so happy. So the catalyst lowers the activation energy, is the key there. Anybody else? Another one. I know Brittany's like shouting them out.
I said heat.
Yeah, heat, increased temperature. So heat gives you your jiggles and giggles. So jiggles equals collisions. So yeah, when you get all hyped up, think of little kids. That's probably why Brittany can think of that, 'cause she's got a lot of little kids in her house. And when they're jiggling and giggling, they start colliding. And the last one, there's a couple of possibilities. If you add a reactant or increase the concentration, somebody the other day said surface area, which would work if you change it into a gas somehow. So this is going to increase the probability of a collision. And that's it. We are done. Unless there's a question. Let's dress up. And I will hang out if people have questions on the worksheet that is due today.